Yeah, hello and welcome everybody to our 2 days webinar. First of all, we want to welcome all of you, all the participants who are interested today to take part in our webinar, and it has today the title, the application range of the new Knauer diode array detector DAD 6.1L. Especially, we want to point out today and to convince you also how accessible, flexible, sensitive, and also robust this detector is. Yeah, and first of all, I want to introduce myself. I'm Mareike Margraf, and I'm working in the Applications and Columns department at Knauer, so I can give you some information about applications and also where the DAD 6.1L is used and where you can perfectly use this in your system. And with me here today is Dr. Kate Monks. Hello, Kate.
Hello, good morning.
And she is a product manager and a specialist for the Knauer detectors, and she can best inform us all about the specifications and the details about the DAD 6.1L. Please just note now, in the end of our presentation we will have enough time to discuss any questions or whatever comes to your mind, so please keep your arising questions or just type this in with the chat function. We will come to that in the end. Yeah, let's shortly look what you can expect today. So first we want to give you a short introduction to our detector, the DAD 6.1L, and after that we will mention who should use the detector and for whom it is perfectly suited. Afterwards, we talk about the flow cells for how to choose the right flow cell for your right applications, and we will also give every time some real-life applications to show you how it is used in real lab praxis. And in the end, there will also, of course, be a short summary where we point out what was really important today to learn for you. Yeah, and now I want to hand over to Kate for the introduction to our detector.
Okay, thank you. So if we have a look here at the picture, we can see the DAD in the middle, and what key aspects of this detector are good and for you as end users? Well, I think the first point is that this detector is extremely accessible. Now, what do I mean by this? If I have a look at the picture on the left-hand side, we can see there is a lamp cover. Just by taking a regular screwdriver, we can unscrew this cap and right from the front can exchange the lamp. And I say we, and I mean all users, your end users. We're not going to need to call a service technician, so at the end of the day, that makes the lamp a lot more accessible. And as well, on the front, in the center of the picture, we can see the flow cell. Just by pressing down the lever, which we can see just above the flow cell, we can easily eject the flow cell from the front there. So that's why this DAD is accessible. He's also sensitive. We've made a huge improvement to the optical bench. We'll have a look at that a little bit later. Also with examples as to showing why this is so much more sensitive than our previous models. The detector is also robust. We've integrated a so-called intelligent temperature control to make it a lot less dependent on the ambient conditions, making our results also a lot more reproducible. But the main focus today is going to be the flexibility of this device. We're going to see how we can use this one device just by changing the flow cell for a wide range of different applications. But like I was mentioning with the accessibility, here we can see how the device looks like when we've taken off that front cover on the left-hand side and how we can access the lamps. The larger circular hole here is the deuterium lamp, the UV lamp, and underneath we can also see the halogen lamp, the vis lamp. As I mentioned, everybody can change this lamp. There are special safety features integrated so that every user can do this autonomously, which also reduces the service costs of this device. On the right-hand side, we can see how the device looks when we have ejected the flow cell. In this case, all of the pictures are with the test cell. Obviously, we'll show a little bit later how this looks like in a real system. Now let's come to the sensitivity of this device. I mentioned that we had changed the optical bench of this device, and here is just a schematic view of what the insides of the detector looks like. The most important point here is that we are blending the two sources of light. So we're blending the light from the D2 lamp and from the halogen lamp through a so-called polka dot design, and there I can move just forward to see the result of this. You can see on the left-hand side, this is our new polka dot design in comparison to the classical shine-through system. And what the result of this is that we have a lot higher intensity over the full spectrum. Also in puncto sensitivity, very important point is the new light guide technology. So two of our flow cells, we've got a standard light guide cartridge flow cell, and we've also got a high sensitivity flow cell with this light guide technology. And what makes these so special is that we've got a total reflection within these flow cells, which gives us the highest possible sensitivity and with an absolute minimum cell volume. It makes these the perfect choice for UHPLC applications. Okay, but how does this actually look like in the lab?
Yeah, for that I brought you a chromatogram from our lab work. So this is a real application that we did in our application lab at Knauer. And here you see a comparison. So just to convince you how well this detector is working, we compared it to our previous model. So on this chromatogram you see exactly the same application with exactly the same column, and anything in the method was the same. And yeah, the blue line is our new DAD 6.1L, and the green chromatogram shows you a different model of detector, so our previous model. And okay, maybe we zoom in a little bit so we see it in a better way. Here already with the standard light guide flow cell, what means this 10 millimeter cell, we will come to that later on, you see that the peaks are higher with our DAD detector, and this is because of the new design of the light guide flow cells. And you see also that the peaks get a little sharper. So peaks are sharper because of the volume and get higher because of the flow path of these cells. And we have another example where again we did the same applications, but here you see we used the high sensitivity flow cell. Again, anything was the same method, same system, just exchange the detector. And again, blue, the DAD 6.1L, and the green line is our previous model. And with this bigger flow cell, you really see much more differences. So peaks are really, really sharp with the new DAD detector, and getting no tailing and get also higher. And why this is the fact, we will talk about that later when you see how the cells are built up and what is the volume of the cells.
Okay, thank you very much. Yeah, I also spoke about the robustness of the DAD. So we've integrated a temperature management, an intelligent one at that, and here with a number of different sensors inside the detector, we can ensure for a short warm-up time, also a stable baseline, and a low temperature, ambient temperature dependence. Before I continue, perhaps I could just ask you, Marijke, I mean, you're in the lab every day. How is it actually to work with the DAD?
Yeah, everything that you mentioned we really saw. So you know, always the product management comes to us, gives us the new detector and tells us how short the warm-up time is and how stable. And then we really take the detector and have a look at it. And in this case, yeah, it's really the fact. So the warm-up time is much shorter than with other models that we used in our lab, so other detectors. So if you you can warm it up and use it after about half an hour. If you want complete stability, okay, you have to wait maybe an hour, but you can really work after 30 minutes, that's no problem. And the baseline is then really stable. And I think this is all realized via this temperature management. So this is the thing that was exchanged in this detector, and we are really convinced with it. So we don't have so much time to wait every morning, and yeah, for that the detector is really nice.
Okay. And as we're here discussing, how often are you sort of changing the flow cells on a day-to-day basis, or how helpful is it that you can change the lamp yourself?
Yeah, for us in the lab, that's a really good thing. So we are working on applications, so we don't do all the time the same applications, but we do method development here. So we exchange flow cells nearly every day, and maybe also 2 times a day. And this is something really nice with this cell, because you don't need any tools, you just click it out, exchange capillaries and choose the other cell, and it is running. You don't have to put anything in the software, it's recognized, and then you can measure again. And also the thing with the lamps, so we have the detector now, we use it for some months, and we didn't have to exchange the lamp.
That's good news.
But we saw in a training that we can do it on our own. So with other detectors, I'm just a user, I'm not a service technician, and with older models maybe I would have problems to exchange the lamps, but with this detector, what I saw, I think I can really do it easily on my own. And I think every user who is a little bit familiar with HPLC and the system can do it on his own.
Okay. Okay, thank you. Okay, so now we come to the question, who should use the DAD? Well, by exchanging the flow cell, the DAD can be used in a number of different fields. Now we've said this, what does it actually come down to? Well, we've got flow cells that are biocompatible, so we're okay for BioLC. We've got analytical flow cells, so we can be using the DAD in our HPLC and UHPC, analytical, of course. But we've also got preparative and semi-preparative flow cells, meaning that we can use this device also for these applications. So which ones have we got? Which flow cells do we have on offer? We have a number, and they are going to be listed out in the following slides. But here I'm going to show you which ones are the best suited for analytical HPLC. So on the one side, we've got the 2 light guide flow cells, that is the high sensitivity and the standard flow cell. But we can also use a so-called Knawa standard flow cell, also as a cartridge design. That will be a 10 millimeter and a 10 microliter in comparison to the 2 microliter light guide flow cell. We can also use this same technology when we employ a so-called fiber optics adapter separately from the flow cell. I'll show a picture illustrating this remote technology a little bit later on. So these are going to be the 4 flow cells that we can choose between for analytical HPLC. Specifically for UHPLC, we're going to be wanting to go with the light guide technology. We saw it a little bit earlier on, that these flow cells with this light guide technology are the best suited for fast separations. We've also got a range of biocompatible flow cells. The light guide flow cells are biocompatible. My goodness. Chewing my words here. But we also have a semi-preparative BioLC flow cell, and also 2 flow cells which are specific for purification tasks. And on the word of purification tasks, we have also a number of preparative LC flow cells. A semi-preparative cartridge flow cell that is going to be coming soon, as well as a selection of flow cells which can be used remotely. Now you'll notice those of you who are familiar with our selection of flow cells, that these are the same article numbers that we already have on our website, and that is definitely a good point here, that we can use we can use all Knauer fiber optic flow cells with this detector. And as you know, we have many of these fiber optic flow cells for preparative LC, and we can use them all with the DAD 6.1L. Now that was a lot of different flow cells. I don't expect any of you to have looked at all of these specs or whatever, but what I wanted to do here was just to show how many different opportunities we have with this device. But let's see, which one are we going to choose for which task? That is the key question in this webinar.
Yeah, maybe I take over now, because the right flow cell for the right application is always something that is, of course, related to the application you are using. And you can imagine, so we just picked out some cases that you have. Maybe we don't cover anything, but these are just examples that we in the applications lab get often these questions. So let's first talk about trace analysis, something really important for many customers of us. So if you are doing trace analysis, what means that you want to detect really, really low concentrations in your samples, and which flow cell would I as a user now recommend for you? Yeah, of course, you all already see the name. It's the high sensitivity flow cell. This flow cell combines, as you can see here, a really long flow path of 50 millimeters. So it's the longest flow path that we can offer here. What means that you get high sensitivity, but also you see here we have only 6 microliter cell volume. And maybe we have a look what exactly does this mean. So here you again see an application example that we did in our lab. And here we combined the flow cells. So we made one measurement. You can see it in the blue chromatogram with our 10 millimeter flow cell, so the standard one, and the 50 millimeter flow cell you see in the green chromatogram. So the green chromatogram is taken with a flow cell that we would recommend for trace analysis. And why do we recommend it? Of course, you see the peaks are getting much higher, and this is because of the longer flow path. So the flow path is 10 times as high as with the standard flow cell. You see, when we look at the right side of our sheet here, we zoomed in one peak, so the second peak in this chromatogram, and you see when we say the blue line has 100% of peak height, you see with the high sensitivity flow cell, the peak height is about 5.7 times as high as with the standard flow cell. And this is something, really striking, and we want just to point out that it isn't really 5 times as high, because you see the peak is also a little bit broadening. So of course, if you have a higher volume, you also have a little bit broader peaks, but here this effect is minimized, and you really get about 5.7 times as high peaks as with the standard flow cell. Okay, now let's go to the next part, something also really often questions in our lab. So the next case would be, which flow cell would I choose if I really need fast analysis and highest resolution? So the high resolution flow cell. And here I would recommend the standard 10 millimeter flow cell, still with the light guide technology. So it's high throughput, high resolution cell, we call it. And we again have a look at the chromatogram we already saw before. So we go back to the example. Here again, the standard flow cell is the blue line, and the 50 millimeter flow cell the green line. And as I told you before, but here we get again to the point that the peaks get sharper with the smaller flow cell. In our example here, the peak width is with a smaller flow cell about 0.016 minutes shorter than with a high sensitivity cell. For really fast applications, this is already something really important. And it indicates that you get the best resolution and the sharpest peaks with this flow cell because of its really, really low volume of only 2 microliters. So 2 microliter is really a low volume for a flow cell. And this is most important if you use shorter columns, for example, smaller particle sizes in your columns, and maybe if you already go a step in the direction of UHPLC. So if you go to fast analysis, short columns, you will see the best results with this flow cell. Okay, what else can we do? So if you want to run standard and routine analysis that are maybe not so fast, and if you use classical HPLC columns and you don't go to UHPLC, but you say you're satisfied with columns like 250 and length and 4 millimeter inner diameter with maybe 5 micron particles, so what we call really classical HPLC in the up to 400 bar range, then you really don't need this high resolution cells. And maybe also you can use the really more price attractive standard Knauer cells. They can be of interest for you now. So the difference here lies in the technology. So there is no light guide technology used, and of course also in the cell volume that you can see here. So you have again a 10 millimeter flow path, but at the same time you also have a cell volume of 10 microliter and not 2 microliter, and it is there with 5 times as much volume as with a high resolution cell. So we would not recommend this cell if high resolution is really needed, or if you use, for example, something like core shell columns. They really need low dispersion volumes in the whole system. So please, if you go to UHPLC and high throughput, high resolution columns, use the light guide ones. But if you are using classical standard routine analysis HPLC, you can also use these more price attractive flow cells. And also you can get these flow cells with some different configurations. Maybe Kate, you can tell us something more about these configurations?
Yeah, well, on the one side, you notice that in the slides that I showed previously, to this particular slide with standard flow cell and the one that we're going to explain a little bit later, we had a nice little orange coming soon sign. Now that is true. They are not yet officially released, but we can still use these flow cells when we use the fiber optics adapter. So it is really worth still looking at these flow cells. And what makes these standard, I call them the standard Knauer flow cells, really quite special is that they can withstand a really high back pressure. So we can go up to 300, they can withstand up to 300 bar back pressure, and they are stainless steel. They're made out of stainless steel. So I'm not going to have to worry about using peak fittings in capillaries, which I do have to look at when I'm using the light guide technology.
Okay, then let's go back to the last point that we have here for our right flow cell for the right applications. And as you maybe know, Knauer is not only active in the field of analytical HPLC and UHPLC, but we also are really going in the field of semi-preparative and also preparative applications in HPLC. And of course, you can also use the DAD 6.1L when you are running prep applications. That's no problem. And here we offer some special high concentration flow cells that have a flow path of only 3 millimeter, as you see here. And okay, maybe now you ask why is that the case. So maybe we just look at a typical chromatogram that we would use in preparative HPLC. So this is again a prep application that we really did in our lab. And here we were interested in the detection and also in the purification of the peak that is here marked with number 1. It doesn't matter at the moment which substance it is because it's only an example for the chromatogram. And you see here something really typical for prep applications. Of course, here you have a really high concentration of your target substance because that is preparative HPLC. You get really high peaks. Here the peaks already is at the limit of what the detector can detect, and there is no need to get something like more sensitivity or anything. So it really is the other way around. Low sensitivity is needed here because of the high concentrations, and therewith here we offer flow cells with smaller flow path for prep applications and for semi-prep applications. They are here really perfectly suited for these applications.
Yeah, and when we spoke about the preparative flow cells, on the right-hand side in common we spoke about remote. The type was a remote. And this is just a photo of the DAD 6.1L that we've got in the product management lab. And you can see here, in the sort of the center of the picture, there is the so-called fiber optics adapter. And this adapter can then be connected with the fiber optics, so they flow, unfortunately, out of the picture, and then they come back onto the left-hand side, flowing into the flow cell. Exactly. There we go. So we can use this sort of configuration. You can see that we've also got a mounting bracket on the left-hand side that is specifically designed for these flow cells. And here we can, as I mentioned previously, here we can integrate all of our standard Kanawa fiber optic flow cells. So we can use this for the preparative, or also if we are interested in separating the flow cell for any reason from the device.
Yeah, that's really a nice example, and thank you for the picture, because also I was a little bit confused. I couldn't imagine how this adapter works, but here it becomes, I think, really clear that it's just the same cartridge and used as an adapter, and with this, yeah, it's connected to our flow cells. So, we are really now at the end of what we wanted to tell you today, and I just want to sum up in the end what was important today and what we want you to take home from our 2 days webinar. So please just keep in mind that the DAD 6.1L is really easy to handle and maintain. So I can tell you that it's really the case to exchange these flow cells is the easiest thing you can do, and I think also the lamp exchange is no problem. The second one is, keep in mind there is a wide range of applications and they can all be carried out on this one device. That is something really nice. So you don't have to use different detectors here. You can, via the exchangeable flow cells, use the detector in nearly any application field when you can use, of course, UV detection. And please keep in mind that for optimum results, the correct flow cell should be selected. So there's a wide range of flow cells and maybe you are confused now. So just keep in mind that we at Knauer are always there for you. So that's really no problem, and I can show you again how you can get in contact with us. So just write us an email if you have any questions. Just contact us and we want to always help you to find the right configuration of your detector and the best fitting flow cell. Okay, now we are really at the end and we have some time for questions. But first let me tell you, if you're interested, you can also get this presentation as a PDF file. You will find it later on our webpage. And now we have, we can just look if there are already questions arising, or we can just tell you, please type in if you have any questions, so we will answer it now or maybe later via email. So everything that you type in here now will be stored, and we can also give you an answer via email later on. So let's see if there are already any questions occurring. Okay, here's one question coming, I see it. And the question is, do I always have to exchange the flow cell for different applications, or can I also use one flow cell? Yeah, maybe I can answer it because I am the one who is using applications and exchanging it. I can tell you no, of course, if you are having one standard flow cell, you can use it for your applications. Of course it will work, but keep in mind, for the best results, we have the best fitting flow cells for you. For example, you only have a standard flow cell, and now you have an application running that needs really, really high sensitivity because your concentrations are so low. Then maybe you can talk to us and we will figure out if these high sensitivity flow cell may work for you. And then you can maybe get better results with a perfect fitting flow cell. But in general, of course, you can run your applications with any flow cell for a first check. That's no problem.
Okay, thank you. And we also have another question here. Do you have anything like a flow cell selection guide? Perhaps I can answer that. Obviously, that's what we've tried to do with this presentation here, is to give you a bit of a guide to which flow cell is going to be the most appropriate. But we can certainly try to put that integrate that to our marketing material and into our product selection guides. But I think what you can really sort of keep in mind is, if you've got trace analysis, use the high sensitivity light guide. If you're looking at high resolution, high throughput applications, you need to use the standard light guide flow cell. If you've got standard applications, you can use the standard cartridge. And if you've got semi-prep applications, you can use the 3mm and 2 microliter flow cell.
Okay, I think I have here one more question, and then I think we have to finish. So the question is this DAD combinable with all Knaur devices, or what do you recommend? So are there recommendations from the product management?
I mean, the DAD, obviously, as part of the Atsura L product line, it is perfect in combination with the P6.1L. Yeah. It's fully integrated into the Open Lab and into the ClarityCon software. But certainly, if there are particular questions, specific questions, then please just don't hesitate to drop us a mail.
Yeah, I think it was really important that you can use it with both our software packages, so it's really suited for anyone using this software. Yeah, I think, okay, we don't have some more time to answer your questions directly, but you hope you got a lot of useful information during our webinar, and now we are looking forward to discuss your questions also via email. So don't hesitate to write us an email. You will see on this slide again our email addresses or also our phone numbers. And when there are still questions arising, maybe later on or tomorrow, sometimes you have to think about it, I know. Also, every question will be answered via mail. And now at the end, we just want to thank you again for joining us, and we wish you, have a nice day and goodbye.
Okay, thank you and goodbye.